In this, our 1997 Powertrain update, we're presenting a lot of information, starting with engines, moving to transmissions and transaxles, then on to drivability, the Ford Quality Renewal Program, and a steering gear topic. To help you locate something of special interest, we've printed the time where each segment starts on the videotape jacket. Just fast forward the tape until the number on the screen matches the number of the topic you want to view. Also, be sure to look through the program booklet that accompanies this videotape. It covers everything in the tape, plus extra reference material you'll find useful on the job. The crankshaft damper assembly transmits crankshaft rotation to the serpentine accessory belt. As the damper reacts to the force of the crankshaft driving it in one direction and the load on the belt providing resistance, it tends to flex. To accommodate this flexing, manufacturing tolerances are fairly wide, plus or minus 20 thousandths of an inch in this case. With this much tolerance, a good damper may appear to walk in and out. This amount of runout is a normal condition for 1996 and earlier 1.9-liter engines. To eliminate belt noise concerns, some techs, noticing the runout and thinking the damper's defective, replace it unnecessarily. Actually, if a belt noise concern exists and damper runout's visible, it's unlikely the two are related. When diagnosing a belt noise concern on the 1.9-liter engine, first determine which belt is involved. If the belt noise is a squeal or a chirp, it probably originates in the front-end accessory drive system. Check belt tension for a squeal. Check pulley alignment for a chirp. If the belt noise is a grating or a warbling sound that's sometimes accompanied by clicks or slaps, or a whine that changes in relation to engine speed, it's more likely due to incorrect timing belt tension. Check the tension of the timing belt. If it requires retensioning, make the adjustment following the procedure in the vehicle service manual. To keep from pre-stressing the belt, be sure the engine's cold and at top dead center before you start. By the way, if you're sure you're dealing with a belt noise but can't determine which one by the methods we've shown, remove the serpentine belt and run the engine. If the noise is still present, the timing belt's the source. If the noise goes away, it must originate in the front-end accessory drive system. The timing belt on the 2-liter split-port induction engine may appear to be loose on this side when the engine stops anywhere other than top dead center. Although one might think that this amount of play means the belt needs to be retensioned or that the engine needs to be timed, neither case is true. If you see this condition when you're servicing the 2-liter split-port induction engine and you haven't done anything to change the timing, ask yourself, was the timing okay before I started the job? If the answer is yes, it's unlikely that the timing's changed. Although it may appear to be loose, the belt is correctly tensioned and retiming the engine is not necessary. The signal hoses that carry exhaust gas to the DPFE sensor have been redesigned due to a noise concern that was associated with the original design. The original signal hoses were ballooning with the exhaust pressure pulses, producing a rattling noise that sounds a lot like an exhaust leak. Typically, it's heard between 2200 and 2500 RPM under load. New design hoses went into production vehicles on August 15, 1996 to correct this concern, and service parts are available now. If an exhaust system leak cannot be found, the source of the noise may be the original design DPFE sensor hoses. Replace them with the new design service parts, being careful not to switch the lines. The original design PCV oil separator on the 2-liter split-port induction engine may have flexed when its fasteners were torqued during the engine build process. This flex may have created an engine oil leak. The leak is likely to be detected soon after the vehicle is sold. The customer may say he smelled hot oil or seen smoke from oil dripping on the catalytic converter. The pan rail also may be damp. The recommended way to verify this concern is to clean the engine around and below the separator. Run the engine until it reaches normal operating temperature. Then view the area with a black light. Because the break-in oil already contains a fluorescent dye, a leak will produce the characteristic fluorescent glow. The solution to this concern is to either reuse the original part with a new gasket or to replace the part with the upgraded PCV oil separator and a new gasket. In either case, torque the assembly to 8.5 to 11 Newton meters. The timing chain on the 2.5-liter Duratec engine in the 1995 Contour and Mystique may clatter or rap when the engine is started after a cold soak of 4 or more hours. If the noise is present, it lasts no more than a couple of seconds and has no effect on engine durability. The cause of the clatter is oil bleed down from the timing chain tensioners when the engine is off. The noise stops when the tensioners are supplied enough oil to operate normally. To verify that the concern exists, allow the vehicle to sit for a minimum of 4 hours, long enough for the tensioners to bleed down. Then start the engine and listen for the noise. If it's present, it'll be heard near the front right side of the engine. When the engine's restarted, the noise will not reoccur. To correct the condition, install the modified 1995 camshaft drive tensioners and adapter plates, and upgrade the entire camshaft drive system to 1996 level components. The modified design tensioners are 1 millimeter thinner than 1996 level production tensioners to accommodate the thickness of the adapter plates. The cavity that's machined into the back of these tensioners creates an oil reservoir that retains engine oil after the engine shut off, enabling the tensioners to actuate sooner. To service the concern, refer to TSB Article 962513 and follow the timing chain removal and installation procedures in the 1995 Vehicle Service Manual. Also note that the left bank and right bank adapter plates are different and are not interchangeable. Refer to TSB Article 962513 to ensure correct installation. To complete the procedure, change the engine oil in the filter using Motorcraft filter FL820 or an equivalent. When the FL820S oil filter becomes available in mid-1997, use it instead of the FL820. The new and more durable silicone bypass check valve in the FL820S will reduce the likelihood of the noise coming back between regularly scheduled oil changes. Until the new design FL820S oil filter becomes available, continue using the FL820. The timing marks on the 2.5-liter and 3-liter Duratec engine's camshaft sprockets were changed in mid-1996 from arrows to characters, and from one set of marks to 2. When setting the timing on the 2.5-liter or 3-liter Duratec engines, be sure to use the correct marks. The set marked RFF, which stands for Roller Finger Follower, the current valve train configuration. The other set of characters is for future applications. Thunderbirds, Cougars, and Mustangs equipped with a 3.8-liter engine and built from Job 1 through January 10, 1996, may weep engine oil around the number 4 front cover to water pump stud. The cause of the leak is the absence of sealant on the end of the stud that threads into the block. If the area around the number 4 front cover stud shows evidence of an engine oil leak, carefully remove the stud, but do not use an impact wrench. Clean and check the condition of the stud. If it's not damaged, reuse it. If it is damaged, replace it. Apply thread sealant D8AZ19554A with Teflon to the stud and install it in the block, tightening it to 8 to 12 Newton meters or 71 to 106 pounds inch. The 4.6-liter 4-valve engine in the Mark VIII has changed to a coil-on plug ignition system for 1997. The coil-on plug system uses a separate coil to fire each spark plug on the compression stroke only. This design eliminates the coil pack and spark plug wires which are present in conventional distributorless ignition systems. By simplifying the system, Ford engineers have enhanced its reliability, reduced its weight, and improved its appearance. With the new system come new diagnostic procedures. Although these are thoroughly covered in the PCED manual, here are some key points. If the PCM detects a misfire and identifies the specific cylinder where it occurs, it will set a misfire continuous memory code for that cylinder. These misfire codes are numbered P0301 through P0308 for the 4.6-liter 4-valve engine. If the misfire condition is random and the PCM is unable to specify a cylinder, it'll set the system misfire code P0300. The PCM also will set a separate primary circuit failure continuous memory code for any coil it determines is faulty. These codes are numbered P0351 through P0358 for the 4.6-liter 4-valve application. The PCM will set a P0350 continuous memory code if it detects a random primary circuit failure but has not identified the specific coil. By specifying the cylinder where a misfire has been detected or the coil that exhibits a primary circuit failure, the PCM simplifies diagnosis. The pinpoint tests in the PCED manual are written to walk you through coil-on plug system concerns in a logical manner, whether you're dealing with a system code or a specific component. For example, for diagnostic trouble code P0350, the system code for an ignition coil primary circuit malfunction, you're directed to start your diagnosis by checking the components that have the highest probability of creating the concern. These include checking the coil and boot for insulation damage, looseness, or shorting, checking the condition of the spark plugs for damage, wear, carbon deposits, and gap, and checking the wiring harnesses for damaged, burned, or overheated insulation, damaged pins, and loose or broken connectors. If the root cause of the concern is located among these items, the defective component is repaired or replaced. The PCM is reset, and quick test is rerun to verify the repair. If the root cause originates elsewhere, the pinpoint tests direct you to check the coil driver line, and the battery line for opens and shorts, and so on until the root cause is pinpointed and repaired. In this segment, we'll demonstrate the correct cam timing procedure for the 5.4 and 6.8-liter engines. This procedure can be performed at the bench during a rebuild or in the vehicle after the oil pump or one or both cylinder heads have been removed. A critical requirement of this procedure is keeping the camshafts and the crankshaft in the correct relationship at all times. By performing the procedure exactly as we demonstrate, valve train or piston damage can be prevented. Before we start, here are a couple of tips that will help make sure the job's done right the first time. When you're ready to install the timing chains, you may find that the copper links are discolored or hard to identify. To work around this concern, here's a way to make sure the chains are installed correctly. Stretch the chain out, placing a single link in a vertical position at one end. The opposite two links will be horizontal. Mark all three with a marking pen. The single vertical link will be aligned with the crankshaft sprocket timing mark. The two horizontal links will be aligned with the camshaft sprocket timing mark. The preload on the hydraulic tensioners must be set before they're reinstalled on the engine. This task must be done carefully to prevent damage to the ratchet assembly. The ratchet assembly will be damaged if it's compressed before the spring tension of the ratchet mechanism is relieved. With the hydraulic tensioner positioned between the jaws of a vise, but with the ratchet arm located safely outside the jaws, compress the tensioner plunger. Then, using a small screwdriver or a pick, push back and hold the ratchet mechanism. While holding the ratchet mechanism, push the ratchet arm back into the tensioner housing and install a paper clip or a similar type of pin into the hole in the tensioner housing to hold the ratchet assembly and plunger in during installation. Remove the tensioner assembly from the vise. Repeat this procedure for the other hydraulic tensioner. Before installing the cylinder heads and camshafts, position the crankshaft keyway at the 12 o'clock position. By doing this, all of the pistons will be below the deck face, allowing you to rotate camshafts later without damaging the valve train or pistons. After installing and torquing the heads, loosely install the camshaft holding tools on both camshafts. Using the camshaft positioning tool, position the left cam sprocket timing mark roughly at 12 o'clock and tighten the camshaft holding tool. Position the right cam sprocket roughly at 11 o'clock and tighten the holding tool. If the camshaft holding tools are not locked while the timing chains are installed, valve spring tension could cause one or both sprockets to jump time after the chains are installed. Next, install the crankshaft tool by sliding it on the keyway. Then install 2 or 3 flywheel bolts in the crankshaft rear flange and using a pry bar, rotate the crankshaft 1/4 turn only in a counterclockwise direction as viewed from the front of the engine. Stop rotating the crankshaft when the slot in the crankshaft tool is aligned and fits over the dowel on the block. If the crankshaft is rotated more than 1/4 turn in the direction shown, or if it's rotated in the opposite direction, piston and valve train damage will occur. Remove the crankshaft tool, but don't disturb the crankshaft position from this point on. Next, position the inner crankshaft sprocket on the crankshaft with the long hub out. Install the left-hand timing chain on the left camshaft sprocket, aligning the single copper link with the timing mark of the crankshaft and the 2 copper links with the camshaft sprocket mark. When the left-hand timing chain is correctly installed, the upper half of the chain will be located below the tensioner guide dowel, and the timing marks will be aligned with the appropriate copper links in the timing chain. To complete this side, install the timing chain guide and the hydraulic tensioner. Now, without changing the position of the crankshaft, install the outer crankshaft sprocket with the long hub facing in. Install the right-hand timing chain, again aligning the 3 copper links with the timing marks. And be sure the bottom half of the right-hand timing chain is installed above the dowel. After installing the timing chain guide and the hydraulic tensioner, remove the camshaft holding tools. Check your work. Verify that all timing marks are properly aligned and turn the engine over a couple of times. This will ensure that the timing chains haven't jumped the sprockets and that the engine isn't binding or sticking. Intake manifold runner control systems are popular with our customers for the enhanced engine performance they deliver. For this and other reasons, more engines are being upgraded to electrically controlled IMROC systems, including the 1997 2.5-liter Duratec in the Contour and Mystique and the 4.6-liter 4-valve engine in the Mark VIII. The PCM controls IMROC actuation based on engine speed and throttle position. The IMROC valve plates typically remain closed at engine speeds below 3,000 RPM to improve low speed and cold engine performance. They typically open at engine speeds above 3,000 RPM to improve high-speed engine performance. Because an IMROC that fails to function correctly may adversely affect emissions, it is subject to OBD2 requirements. For this reason, the IMROC is equipped with an internal monitor switch that provides feedback to the PCM. Diagnostic trouble codes will set, and the malfunction indicator lamp will illuminate if the PCM detects the valve plate stuck open or stuck closed. Other diagnostic trouble codes will be set, but the mill will not light if an open or short is detected in the IMROC circuitry or if the monitor switch signal is out of range. In addition to the change to an electrically actuated IMROC, the 1997 Mark VIII is equipped with a center entry throttle body. It's similar to the throttle body on the 4.6-liter four-valve engine in the Mustang. To learn more about the intake manifold runner control and other intake air systems and how to diagnose concerns related to them, refer to the system descriptions and pinpoint tests in the PCED manual. The hurdle that petroleum refiners must meet to earn the API certification mark has been raised. The combination of tougher standards plus new refining technology is resulting in the production of base oil stock that's so pure, it's as clear as water. The impurities which are present in conventional refined base oil stock cause lubricants to degrade. By removing the impurities, refiners have developed petroleum-based lubricants that exhibit synthetic-like characteristics. When blended with the required additives, the base oil stock takes on the color, texture, and smell of conventional lubricants. The standards the new engine oils must meet include improved fuel efficiency, resistance to foaming, improved low temperature viscosity, improved volatility, and emission system protection. To make sure you're getting the best oil for your engine, insist on a product that carries this certification mark. Ford is standardizing the markings on its engine oil dipsticks. Although there are several styles now, there'll be just one in 1999. The new dipsticks have min and max markings only. When the oil level is at the min mark, only 1 quart can be added. If the oil level is between the marks, oil should not be added. Adding oil when the level falls between the min and max marks may overfill the crankcase, causing foaming and potential camshaft bearing damage. When you're checking the oil on an engine equipped with a cable and bullet dipstick, wipe it thoroughly, especially the flat area. Although some oil will adhere to the outside of the bullet when you withdraw the dipstick, the marked flat surface will be partially dry. The new min and max marked dipsticks were introduced on the 2-liter Zetec and the 2.5-liter Duratec engines in Contour and Mystique for 1995. You'll find them in the 1996.5 5-liter Explorer engine and in the 1997 4.6-liter 2-valve engine in the Crown Victoria Grand Marquis and Town Car. Although the cooling systems for the 2-liter Zetec and the 2.5-liter Duratec engines don't appear much different than the conventional systems we grew up with, they are unique. Each is an example of a DeGas system, a design that's fully pressurized, including the coolant recovery or DeGas bottle. To help you understand how a DeGas system differs from a conventional cooling system, 2 things need to be cleared up. The first is how the system removes air from the coolant. The second is the misconception that the DeGas bottle is merely an overflow container. When the top of the radiator is the high point in the cooling system, air bubbles in the coolant collect there and vent through the cap. In many of today's vehicles, however, some of the coolant passages in the engine are higher than the radiator. If there were no way to remove air from the engine, it would be trapped, reducing cooling system efficiency. The DeGas system gets the bubbles out by continuously purging air from the cylinder block and circulating air-free coolant back to the engine. This promotes effective cooling by keeping a solid wall of coolant in contact with the cylinder walls at all times. A conventional overflow system only works when the engine's off, allowing hot liquid to escape from the radiator and return when cooled. None of this back and forth flow takes place in a DeGas system. The DeGas bottle is an integral part of the cooling system while the engine's running. The coolant must flow to the bottle to release air bubbles before it's permitted to re-enter the coolant stream. Immediately after the engine shut off, coolant temperature spikes briefly. The added system pressure opens the pressure valve in the fill cap and vents air to the atmosphere. As the coolant temperature drops, the air pressure in the DeGas bottle decreases. In response, the greater pressure outside the bottle forces air into the bottle through the vacuum valve in the fill cap. To operate correctly, the DeGas system requires this cushion of air above the coolant. If the bottle's overfilled, liquid may vent after the engine's shut off. If the level's too low, overheating concerns may develop. When servicing a DeGas system, be sure to heed the warnings in the vehicle service manual. The coolant is extremely hot, as high as 230 degrees Fahrenheit at the DeGas bottle. To prevent cooling system concerns, be sure the coolant level is between the min and max marks when the engine's cold. Tighten the fill cap to 4 Newton meters torque. That's hand tight. A loose cap may be the cause of an overheat concern. And verify that the fan works properly at both low and high speeds. Serpentine accessory belts are often replaced when they have plenty of life left in them. Here are some tips to help you determine when a belt should be replaced. Do not replace belts that have cracks across the ribs. Although the cracks may appear at less than 50,000 miles under severe operating conditions, they neither weaken the belt nor interfere with its performance. Do replace a belt if it's missing chunks of rib material as long as 5 millimeters or 19/100ths of an inch. These are signs of belt failure. When in doubt, check the belt cracking, chunking, and wear guidelines in the vehicle service manuals. The 1997 E4OD automatic transmission features a number of changes. The first of these is a cooler bypass valve, or CBV, that's present on F-150 and F-250 light trucks under 8,500 GVW, and on all Expedition and Econoline equipped with E4OD transmissions. The cooler bypass valve was added to achieve faster fluid warm-up during cold weather operation. Although some of the transmission fluid still travels to the cooler, a portion is diverted back into the unit by the cooler bypass valve, helping achieve faster warm-up. When servicing the valve, follow the procedures in the vehicle service manual. The CBV assembly should be removed and backflushed during an overhaul to remove contamination. To overcome the tension of the internal check ball and allow fluid to pass through the valve, regulate solvent pressure to at least 344.75 kPa or 50 psi. Also note that the rubber-coated aluminum sealing washers can fall off the valve. Clean and inspect these washers and replace them if they're damaged. Avoid over-tightening the fittings when reinstalling the valve on the transmission. Over-tightening can damage the rubber-coated washers and may strip the case threads. If replacement of the entire CBV assembly is required, remove the O-rings and shipping caps before installation. Another change that applies to all 1997 and some late 1996 model applications is the number 10 thrust bearing and forward ring gear hub. The thrust washer that was present between the forward planet assembly and the forward ring gear hub in past units has been replaced with a needle bearing. To accommodate the needle bearing, the forward ring gear hub was changed as well. The slots in the forward planet carrier that held the thrust washer in place were also removed. When servicing these components, Service Kit F7TZ 7B067AB can be used. This kit contains one number 10A needle bearing, one mating forward ring gear hub, and an instruction sheet. Make sure both parts in the kit are used. Old and new design components cannot be mixed. This kit, which should be available soon, will service any E4OD transmission regardless of which forward planet carrier design is used. Another across-the-board change for 1997 is a new design overdrive piston and cylinder. This change will occur as a running change sometime during the 1997 model year. In past models, the piston had separate inner and outer lip seals. The new design has a one-piece seal that is bonded to the piston. The cylinder design changed to accommodate the new piston design. Avoid mixing parts when servicing the overdrive clutch. The old design and new design pistons and cylinders are not interchangeable. Refer to TSB Article 962115 until these changes are fully incorporated into the 97 models. Some 1997 E4OD transmissions and a small number of 1996 units contain a new design overdrive ring gear and retaining rings. This also will be a running change sometime during the 1997 model year. The thick center shaft retaining ring is replaced with a thin wave ring. The thick one-way clutch retaining ring is replaced with a thin flat ring. The new ring gear has a lead-in chamfer to simplify center shaft installation. Refer to TSB Article 962117 until these changes are fully incorporated into the 97 models. To prevent misbuilds when any one of these components needs to be replaced, replace all three components with the correct current level parts. The new ring gear, when purchased, will come with the new style retaining rings. Make sure the rings are properly seated in the grooves, otherwise a repeat repair will occur. Another change to many 1997 E4ODs is the presence of a digital transmission range sensor and accompanying changes to the manual shaft and outer lever. The digital TR sensor will not retrofit to prior model year transmissions. The new one-piece manual shaft and outer lever, although similar to the 89 through 92 style, is not interchangeable with them. The E4OD changes we just covered are also presented in the program booklet. The application chart shows which of the enhancements is present in applications based on gross vehicle weight and vehicle line. Refer to the booklet when you're servicing a 97 E4OD to avoid misbuilds. To complete the discussion of the E4OD, here are several reminders about topics that recently appeared as TSB articles. E4OD transmissions are equipped with a converter drainback spring and stop assembly in the stator support of the pump control body. This spring and stop assembly must be replaced during an overhaul. Failure to do so may lead to a repeat repair. The spring can act like a filter, trapping contaminants suspended in the fluid. With enough buildup, the flow to the coast and overdrive systems may be restricted. Symptoms include heat distress on the overdrive planetary gear set, the coast clutch cylinder bushing, or the overdrive cylinder bushing. The converter drainback spring and stop assembly and the required orifice cup plug are currently available in kit number E9TZ 7H132B. It will also be added to the E4OD soft seal kit part number FOTZ 7153A in the near future. E4OD transmissions built after August 7, 1995 contain a new design intermediate band apply servo assembly, part number F6TZ 7D021A. The new assembly will service all past and current E4OD transmissions. When the intermediate band apply servo assembly needs to be replaced, Exercise caution to prevent mixing parts. To use the old design in a new transmission, the case must have a groove for the retaining ring. If there is no retaining ring groove in the piston bore, only the new design assembly can be used. When replacing the old design with the new assembly, do not reuse the old retainer and retaining ring. They're not needed. To remove the new design, gently tap on the piston rod protruding from the top of the piston with a rubber or plastic mallet. The spring load from the tap will pop the servo assembly up enough to be removed. To install the new design, lubricate the piston seal with transmission fluid and slide the servo assembly into the case bore until the assembly is just below the top of the bore. TSB Article 96728 provides information that will assist you in selecting the correct components when servicing the reverse clutch piston. The 1996 model year changes included the addition of a wave plate spring to the reverse clutch pack, a change in the depth of the reverse clutch piston to accommodate the wave plate spring, a change to the retainer and spring assembly also to accommodate the wave plate spring, and a change to the inner and outer piston seals from square cut to lip seals. These parts are not interchangeable with past models due to accompanying calibration changes. To prevent a misbuild when replacing any reverse clutch component, refer to the part usage chart in TSB Article 96728 or in the program booklet. The 1997 CD4E transaxle contains a new crimp nut designed park lever assembly and a redesigned park pawl ratchet spring that's blue in color. The new ratchet spring can only be used with the new park lever assembly. If the park lever assembly in a 1997 CD4E transaxle needs to be replaced, install the crimp nut design assembly, part number F6RZ 7R392AA. The components that comprise the assembly cannot be ordered individually. If the spring also needs to be replaced, install the blue park pawl ratchet spring, part number F7RZ 7A180AA. These components will not retrofit to earlier model year CD4E transaxles, nor will earlier model components function correctly in a 1997. Additional information on this topic is included in the booklet that accompanies this tape. Also beginning with the 1997 model year, the CD4E transaxle contains a new design main control assembly, part number F7RZ 7A100AA. This new design includes a new intermediate overdrive accumulator valve plug, but is no longer equipped with a pull-in control valve, spring, and retaining plate. If replacement of the main control assembly is required on a 1997 CD4E transaxle, service it with the new design assembly only. This assembly cannot be used on earlier model year vehicles because it's also accompanied by changes to the intermediate overdrive servo assembly and PCM. The CD4E in the 1997 probe contains a new design one-piece intermediate overdrive servo piston and rod assembly and a redesigned intermediate overdrive servo piston return spring assembly that's green in color. If the intermediate overdrive servo piston and rod assembly in a 1997 CD4E transaxle requires replacing, service it only with the new design select fit piston and rod assembly. Instructions for determining the correct select fit assembly are provided in the program booklet. Also be sure that only the green return spring, F7RZ 78073AA, is used with the new design piston and rod assembly. These new components cannot be used on previous model year vehicles because they're a coordinated change with the 1997 main control and PCM. The one-piece intermediate overdrive servo piston and rod assembly and the redesigned return spring will be implemented in the Contour and Mystique in January 1997. Although some driveline noises are symptomatic of component failure, wear, or misadjustment, others are normal. The customer needs to know that. TSB Article 9687 describes noises which may be exhibited by AX4S and AX4N automatic transaxles. It was published to help you know which noises are normal and are to be expected. We've reprinted TSB Article 9687 in the booklet that accompanies this tape and added another noise concern too, a clunk in Windstar vehicles. The clunk may be heard when the transaxle shifted out of park when the vehicle's parked on an incline. The clunk occurs when the weight of the vehicle is taken off the park pole. To learn more about servicing AX4S and AX4N noises, refer to TSB Article 9687 and the program booklet. You'll find that a number of noises are either normal or should not be serviced at this time. A number of 4x4s equipped with AODE, 4R70W, C6, or E4OD automatic transmissions may develop a transmission fluid leak from the extension housing into the transfer case due to the failure of the original transfer case input shaft seal. To see which vehicles may be affected by this concern, check the list in the program booklet. The customer may report a drop in transmission fluid level or shift or engagement concerns. To diagnose the concern, check the fluid level in the transmission. If the fluid's low and there are no visible leaks, check the transfer case fluid level. It should be just below the fill plug hole. If the transfer case is over full and the transmission fluid's not burnt, remove the transfer case and install the new double lip design seal, part number F77Z 7B215AA. Loctite's not required with this seal. If the transmission fluid is burnt, repair the transmission as required and then replace the transfer case input shaft seal. When finished, adjust the fluid levels in both the transmission and the transfer case. A new case and main control are available to service certain 1992 through 1995 AODE and 4R70W automatic transmissions. When servicing an existing unit with either a new case or a new main control, the correct pilot sleeves and bolts must be installed to prevent a misbuild. The new transmission case pilot holes are smaller to match the smaller pilot bolts used in the new service main control. When replacing only the case and reusing the original main control, replace the original pilot bolts with small-tipped N808962S bolts and gasket number F6AZ 7C155A. Use the large-tipped pilot bolts to assemble the main control. They align the separating plate and the valve body gasket. After the main control is assembled, remove and replace the large-tipped pilot bolts with the new bolts. The reinforcing plate and separating plate bolts will keep the components aligned. When replacing only the main control and reusing the case, install sleeves F6AZ 7K720A in the main control pilot holes. And remember to install the new EPC solenoid retainer, part number F6AZ 7H111A. The necessary parts are all listed in the parts catalog. 1997 F-150 4x2s equipped with 4R 70W transmissions may develop a transmission fluid leak from the extension housing to case joint when equipped with the original paper gasket. The leakage may be misdiagnosed as a fluid pan gasket leak and lead to unnecessary pan gasket replacement and a repeat repair. The cause of the concern may be the load that's placed on the extension housing to case joint by this exhaust system bracket. When servicing a vehicle for this concern, replace the original gasket with the new steel-backed gasket, part number F6AZ 7086A. The silicone bead around its edge provides improved sealing. To avoid preloading the extension housing to case flange joint and provide clearance for the extension housing mount bolt installation, you can enlarge these holes as much as 1/8 inch at the front and rear before installing the bracket. When reassembling the bracket, tighten the nuts on the exhaust system end first. Then install and tighten the through bolts to the extension housing mount flange. Due to a limited supply of service main controls for the AODE automatic transmission, you may be unable to obtain the valve body that's specified for the unit, part number F2UZ 7A100A. If you must replace the main control on a 1992 or 1993 5-liter Econoline, install the F-Series valve body, part number F1TZ 7A100B, to prevent a vehicle down concern. And make sure to use the correct gasket, since using the wrong one may cause shift concerns or damage the transmission. Using this alternate main control on the AODE may result in busy shifts or early 3-4 or 4-3 shifts. If you notice these symptoms when you test drive the vehicle after making the repair, inform the customer and arrange for a callback when the correct part's available. Also be sure to have the original main control shipped to the Ford Quality Renewal Center. The address is provided in the program booklet. Ford introduced a new 5-speed automatic overdrive transmission at the start of the 1997 model year, the 5R55E. It's paired with 4-liter engines in the Ranger, Aerostar, and Explorer, replacing the 4-speed 4R55E. The 5R55E is the first 5-speed automatic transmission in a compact truck. It's built to last. And it provides improved acceleration and off-road operation, as well as a 500-pound increase in trailer towing capacity. As the gear ratios show, Ford engineers split the difference between the 4-speed's first and second gears to create the 5R55E's new second gear. This means that shifts are smoother for greater operator satisfaction and transmission durability is enhanced. The 5R55E and the 4R44E share many of the same components. In fact, the two are almost entirely compatible. For example, both are factory filled with a new transmission fluid. The service version of this fluid is Mercon 5. Mercon 5 is currently approved for use in the 1997 4R44E and 5R55E, and engineers are currently advising against mixing it with regular Mercon automatic transmission fluid or using it in other transmissions or transaxles. Under normal duty conditions, Mercon 5 is a fill-for-life fluid. Under severe duty conditions, it should be changed at 50,000-mile intervals. Mercon 5 has improved viscosity to better protect the internal components of the transmission. It flows faster at low temperatures for better cold weather operation. And it's formulated to protect the 4R44E and 5R55E friction clutches, needle bearings, and gears. The 4R44E and 5R55E also are equipped with directional coast clutch, direct clutch, and forward clutch friction plates. The grooves control fluid flow across the plates, reducing heat buildup and extending clutch life. When the friction plates are serviced, they must be oriented correctly to prevent transmission damage. Installation instructions are provided in the vehicle service manual. These directional friction plates are not compatible with past model year transmissions. Both units also are equipped with the new digital transmission range sensor. This is a topic that we'll cover in greater depth a little later in the video. The 1997 4R44E and 5R55E are equipped with new design solenoids. These solenoids produce a significant current change when they move. This current change, which we refer to as an inductive signature, informs the PCM that the solenoid responds mechanically when it's turned on and off. If the PCM does not see a current change when it commands a solenoid to move, it sets a diagnostic trouble code. The solenoids affected by this change include all shift solenoids, the torque converter clutch solenoid, the electronic pressure control solenoid, and the coast clutch solenoid in the 4R44E only. The new design solenoids are not interchangeable with past model year transmissions. Prior to the 1997 model year, the fluid pump stator, the center support, and the forward clutch were equipped with bushings. For 1997, these bushings are replaced with needle bearings. The 1997 parts and those they mate with are not compatible with the earlier designs. The rear case bushing also is replaced with a new design needle bearing. If the rear case needle bearing needs to be replaced, remove it using the bushing remover. When installing the new needle bearing, orient the gold ring toward the tool and use the new design installer. It seats the bearing to the proper depth. Another change for 1997 is the presence of a new design converter housing hub seal that does not require staking. To install this seal, use the new converter hub seal installer, part number T97T77000A. When servicing past model hub seals, check the converter housing for a step. Use only the stepped staked seals on housings with the step. Always service the converter with the same type seal that was removed. The front servo assembly in the 5R55E is a new design, and a special tool, the J-hook, has been developed to simplify its removal. The J-hook is inserted into the case, rotated, and pushed against the servo pin. The pin, cover, and servo push out easily. Using the J-hook to remove the servo assembly prevents damage to the servo cap and bore. This tool is compatible with and should be used on earlier models. One area in which the 5R55E and the 4R44E truly differ is in diagnostics. Although the transmission tester must be used to check the digital transmission range sensor on the 5R55E, the NGS must be used to check the operation of its shift, torque converter, and EPC solenoids. The NGS contains a new software program called Output State Control. With it, bench and drive mode tests can be run that are similar to those that are available for other units with the transmission tester, but more powerful. Output state control enables you to override normal PCM control of the transmission solenoids. You can command the shift, torque converter, and electronic pressure control solenoids on or off to check their circuits. And you can control when shifts occur, a valuable feature when duplicating a customer concern. The diagnostic procedures for the 5R55E are located in the vehicle service manual. To learn more about the 5R55E, refer to these TSB articles. 961724 describes the 5R55E's features and major components. 96185 tells what to do if you find an orange service tag on the pan of a unit you're servicing. To complete our discussion of this family of transmissions, here are 3 important reminders about topics that first appeared as TSB articles. TSB Article 96320 was issued to inform technicians that transmission screen and gasket kits F5TZ 7A098A and F5TZ 7A098B contain the incorrect pan-to-case gasket. When servicing a 4R44E or 4R55E, do not use the pan-to-case gasket that's supplied with these kits. Using this gasket will result in a fluid leak. Instead, use gasket number F5TZ 7A191A. This gasket is thicker and contains torque limiters. New service kits are now available. Refer to the parts catalog for part numbers and applications. TSB Article 96321 discusses the internal wiring harness change that occurred for 1996 4R44E and 4R55E transmissions. If the internal wiring harness on a 1995 or 1996 unit is replaced with the new version, the new, deeper fluid pan also must be installed to prevent wiring harness damage or a fluid leak. TSB Article 96419 discusses transmission overhaul and seal kit FOTZ 7C391B. This kit contains some components that can be used only in the A4LD transmission. If the parts that are unique to the A4LD are used in a 4R44E or 4R55E transmission, catastrophic damage to the unit or test equipment damage will occur. When you're using the A4LD kit to service a 4R44E or 4R55E transmission, unique parts must be ordered separately. This information is printed in the part usage charts in the TSB article and in the booklet that came with this videotape. New service kits are now available. Refer to the parts catalog for part numbers and applications. When replacing a TR sensor harness connector, the rubber grommet that's located at the rear of the connector should be removed before any wires are pushed through it. We've learned that inserting wires through the grommet while it's still in the hard shell may cut the rubber and lead to water intrusion, contamination, increased resistance, and faulty signals to the PCM. To prevent this concern, insert each terminated wire through the back lock, then through the rubber grommet, and install the terminal in the hard shell. When all terminals are properly installed, slide the grommet into the hard shell housing, slide the back cover onto the connector and snap it in place, then install the red pin separator. All 1997 light trucks and most rear-wheel drive passenger cars are equipped with a digital transmission range sensor. The digital design is more robust than its predecessor, so it's more durable and less likely to produce noisy signals. The digital TR sensor employs switches, not the sliding contacts that are present in conventional designs. In overdrive, the contacts are open, so there's nothing to wear out. The pinouts also are identical across all applications, and the pin assignments are the same, simplifying diagnosis and service. To diagnose the digital TR sensor, use the transmission tester, the new digital TR sensor overlay, part number 007-00131, the TRE cable, part number 007-00111, and follow the appropriate pinpoint test in the service manual. To set up the E cable, Switch it to the digital setting and connect its black connector to the sensor. The transmission tester manual is also revised and includes all units and applications since electronic controls were introduced in Ford automatic transmissions and transaxles. All of the transmission tests also are located in the service manual for the application. When you're rebuilding or replacing a transmission or transaxle, cooler flushing is the best insurance against a repeat repair. Flushing with the right equipment, the Rotunda torque converter, oil cooler cleaner, or an equivalent machine removes metal and fiber particles from the cooler so they won't contaminate the nice clean transmission you took so much care to service. Start the process early while you're completing reassembly, for example, and flush 20 minutes in each direction. When the job's done, blow out any remaining solvent with a light flow of air. High pressure air may damage the cooler's internal components. Also avoid using aftermarket flush-in-a-can products. They're no substitute for doing the job the right way, and they may damage seals. Use only the recommended equipment and mineral spirit-based solvent. Ford recently issued new guidelines which will take the guesswork out of diagnosing and servicing torque converter assemblies. These guidelines will be published in an upcoming TSB article and are reprinted in the program booklet. When the procedures are followed, fewer good torque converters will be changed unnecessarily. The diagnostic procedures will look familiar. They closely parallel the diagnostic flow chart that's been a part of the transmission and transaxle reference manuals for years. If a thorough diagnosis indicates that the torque converter does not function correctly, is damaged, or is excessively worn, it must be replaced. It also must be replaced if there is evidence of fluid contamination due to a major metallic failure, multiple clutch or clutch plate failures, or component wear that is sufficient to cause metallic contamination. After a torque converter assembly is replaced, the procedures require flushing in both directions of all coolers and cooler lines to remove contaminants and flow testing of the transmission cooler. A lot of techs don't realize that the time they spend diagnosing a concern can be paid time, that there's a labor code they can charge against, even if the diagnosis fails to pinpoint the root cause. If, after performing the diagnostic procedures in the service manual, you eliminate the transmission as the source of the concern, enter "no problem found" on the repair order and charge labor code 7000F, electronic transmission diagnosis. Doing so enables you to be paid for your time. If the root cause of the concern is determined to be a component, the time spent performing diagnosis attaches to the part. A number of passenger cars built between 1992 and 1995 and equipped with the AODE or 4R70W automatic transmission may exhibit torque converter shudder under light to moderate acceleration at speeds above 35 miles per hour. The shudder or vibration typically occurs in third or fourth gear or during a 3-4 or 4-3 shift. The root cause of the condition is automatic transmission fluid breakdown. If diagnosis confirms the condition, here's how to service the concern. If the shudder occurs below 7,000 or above 20,000 miles, change the transmission fluid, including the fluid in the torque converter, the cooler, and the cooler lines. This will eliminate the concern in 90% of vehicles. If the shudder occurs between 7,000 and 20,000 miles, the cause may be hardware related. To service these vehicles, remove the transmission, replace the torque converter assembly with the correct service part. Reuse the transmission pan gasket and filter if they're not damaged. Then install the transmission assembly and fill it with Mercon automatic transmission fluid. Also verify that the fluid is not contaminated with moisture. Use quart containers of Mercon fluid to ensure fluid quality. If a service converter is not available for one of these vehicles, change the fluid as a temporary action until the correct service part can be obtained. For additional details on this concern, the vehicles affected, and the correct service procedure, refer to your program booklet and the upcoming TSB article. A new tool was recently developed to simplify the disassembly and reassembly of the Mark VIII steering column. It's the tilt spring compressor, part number T97P 3D655A. After removing the steering column from the vehicle, following the steps in section 21104 of the service manual, remove the tilt and telescope motors. Remove the housing cover. Then remove the tilt spring using the tilt spring compressor. To do this, install the tilt spring compressor and tighten the screw finger tight. Remove the telescope actuator retaining bolts. Slowly turn the tilt spring compressor bolt counterclockwise to release the spring tension. Then remove the tilt spring compressor and the tilt spring. Continue the disassembly as directed in the service manual. When reassembling the steering column, use the tilt spring compressor when you're ready to install the telescope actuator retaining bolts. Install the tilt spring compressor. Turn the bolt clockwise until the bolt holes for the telescope actuator align. Install the telescope actuator retaining bolts. Then, with the tilt spring securely in position, remove the tilt spring compressor. Continue reassembly following the steps in section 21104 of the service manual. Some 1996 and early 1997 Taurus and Sable vehicles may exhibit a grunt or groan noise when the steering wheel is returned to center after a hard right turn. The noise may be due to the steering gear valve sleeve creating a noise that resonates through the steering system. To service this concern, follow the procedure in TSB Article 96.19.2. It tells you to replace the steering gear to power steering filter hose with a revised power steering return hose, part number F7DZ 3A713AA. The revised hose consists of more rubber hose and less metal tubing than the original and uses an internal spring to dampen resonance. When removing the original hose, be careful not to damage the filter. When you connect the revised hose to the filter, use only the clamp that's packaged with the hose. This constant tension clamp is designed to withstand the high fluid pressure in the system. The use of screw type or other clamps may lead to fluid leakage. If the bracket that's attached to the revised hose has a tab, bend it flat. This tab is required for installation in the 1997 Taurus Sable, but not for the 1996 models we're discussing. Be sure to attach the bracket securely to the subframe and replace the heat shield near the exhaust manifold if removed. On completion of the repair, refill the power steering system with Mercon multi-purpose automatic transmission fluid and purge air from the system. Instructions for purging the air from the system can be found in section 110026 of the service manual. The brackets that are used to secure the power steering lines are designed to prevent normal power steering sounds from entering the passenger compartment. If a power steering hose is incorrectly fastened or misrouted, it may touch body parts, heater hoses, or other components and transmit noise into the passenger compartment. Customers may complain of a low-frequency moan or a growl when the wheels are turned, or a high-pitched whine when there's little or no pressure on the system. These noises may be mistakenly diagnosed as a failed power steering pump. Before replacing a power steering pump that's probably okay, check the routing of the power steering lines. Verify that attachment points are tight. Verify that the system is filled with fluid. Make sure there are no leaks which might allow air into the system. And verify that the noise does not originate elsewhere with another engine component. Although evaporative emission systems are configured in different ways, they serve the same purpose. They prevent fuel vapors from escaping into the atmosphere. Because an evaporative emission system must comply with OBD2 regulations, it's closely monitored by the PCM for component failures and leakage. If a leak's detected, the PCM sets a diagnostic trouble code and illuminates the malfunction indicator lamp. This program deals with a recent EVAP system design, the Evaporative Emission Running Loss Monitor System. We'll show how it works in a light truck application and demonstrate how leakage concerns are diagnosed. The Evaporative Emission Running Loss Monitor System in this F-150 consists of these components: the fuel tank, the fuel filler cap, the fuel vapor valve, the fuel pump sender fuel level input wire to the PCM, 2 1-liter fuel vapor storage canisters, the fuel tank pressure sensor, the vapor management valve, the canister vent solenoid, the PCM, and the connecting wires and fuel vapor hoses. Vapors from the fuel tank and crankcase are continuously vented into the vapor storage canisters, whether the engine is on or off. The activated carbon that fills the canisters traps the vapors, preventing them from escaping into the atmosphere. When the engine is on and operating within a prescribed set of conditions, the vapors are purged from the canister and burned in the engine. The fuel filler cap seals in fuel tank vapors and prevents spills. If it's not tightened securely, or if it's been replaced with an aftermarket cap that doesn't seal correctly, the PCM will detect a leak when it runs the monitor test. Fuel vapors are vented through the tank-mounted fuel vapor valve to the storage canisters. Although this is sometimes referred to as the rollover valve, it's actually 2 valves in one. The head valve portion prevents the fuel tank from being overfilled during fueling. The rollover valve portion prevents fuel from entering the vapor line that leads to the canisters. If a rollover occurs, the float closes when the liquid fuel reaches the orifice. The fuel tank pressure sensor responds to changes in fuel tank pressure or vacuum. The PCM monitors the sensor's signal at key on, engine off, and while the engine's running. The input from the fuel tank pressure sensor is used during the EVAP monitor test to indicate if a leak exists. The PCM controls the canister purge rate by increasing or decreasing the duty cycle it applies to the vapor management valve solenoid. When the engine is turned off, the vapor management valve closes, forcing vapors to flow to the canisters. The canister vent solenoid is used during monitor testing only. To initiate the test, the PCM applies a 100% duty cycle to the canister vent solenoid. With the canister vent solenoid closed, the EVAP system no longer has a source of purge air. As a result, intake manifold vacuum draws down the vacuum throughout the system. The Evaporative Emission System Monitor Test detects component failures and leakage. Before the PCM starts the test, a number of conditions must exist. The pressure or vacuum in the fuel tank must not be excessive. The intake air temperature must be warm. The engine must be warm, stable, and running at a moderate load and engine speed. Closed-loop fuel control must be enabled. And the vehicle must be moving at a steady speed, typically between 40 and 70 miles per hour for a period of time. When these conditions are met, the PCM closes the canister vent solenoid but keeps the vapor management valve open to draw down the vacuum in the system. When system vacuum reaches a predetermined level, the PCM closes the vapor management valve, sealing the system completely. By monitoring the fuel tank pressure sensor signal, the PCM is able to determine if a leak is present. A rapid vacuum loss suggests a large leak, while a slower vacuum loss suggests a small leak. If the PCM detects a small leak, an opening of about 40 thousandths of an inch, it sets diagnostic trouble code P0442 and illuminates the mill. If it detects a gross leak, the PCM sets diagnostic trouble code P0455 and turns on the mill. The PCM also sets diagnostic trouble codes if a component or another system failure is detected. For instance, code P0446 is set when the fuel tank pressure sensor informs the PCM that pressure in the fuel tank is too low. The root cause of DTC P0446 may be a fault in the FTP sensor or its circuitry that results in false information being sent to the PCM, or conditions that physically block the flow of vapors, such as a kinked or blocked fuel vapor hose, a restricted canister vent, a damaged canister vent solenoid that causes the valve to stick closed, or a damaged canister vent solenoid filter. Diagnostic trouble code P1450 is set when the system is unable to bleed up system vacuum after closing the vapor management valve. This may be due to a kinked or blocked fuel vapor hose, a restricted canister vent, a damaged canister vent solenoid that causes the valve to stick closed, a damaged canister vent solenoid filter, a damaged vapor management valve that causes the valve to stick open, an open in the fuel tank pressure sensor reference voltage circuit that interferes with communication with the PCM, or faulty signals from a damaged fuel tank pressure sensor. Other codes will be set if faults are present elsewhere in the system circuitry. To locate a leak in the EVAP system, use the Rotunda Evaporative Emission System Tester or an equivalent device. When using the tester, follow the instructions which are provided in the tester kit and refer to the PCED manual or SBDS for step-by-step guidance as you check the system. Also refer to SBTS and the most current CD-ROM for the latest diagnostic updates. Using an inert gas like nitrogen or argon, pressurize the system at the service port to the level specified in the PCED manual. Never use oxygen or any other gas that promotes or accelerates combustion. Then check the hoses, connections, and fuel filler cap with the ultrasonic leak detector. Avoid using soap solutions like Snoop around the fuel filler cap. Some brands are known to damage the cap's O-ring, resulting in vapor leakage. If a leak is not detected with the compressed gas fitting connected to the test port, attach the fuel filler cap adapter, repressurize the system, and check the test port itself. After all, it could develop a leak. After locating the leak, make the required repair, clear stored codes, and perform the EVAP monitor repair verification procedure. When you've diagnosed an engine or a transmission concern and come to the conclusion that a major repair or an overhaul is needed, you can make the repair yourself, a costly and time-consuming chore, or you can call the people at the Ford Quality Renewal Program for a remanufactured unit. Ford Quality Renewal engines and transmissions contain all the latest upgrades and are available for nearly all vehicles. A complete list is provided in your booklet and in the accompanying chart. If you're not quite sure when it's better to call for an FQR product or do it yourself, here are some guidelines to simplify the decision. If an engine needs to be removed from the vehicle for a major repair inside the block, you're better off calling for an FQR engine. If a transmission shows signs of hard part failures like burnt fluid or metal contamination, ordering an FQR unit usually is the best choice. The price tag of all those service parts adds up fast. After the Ford quality Renewal engine or transmission's installed, there's one thing left to do before your work's done. Fill out the paperwork and return it to Ford.
Here you go, Mike.
Okay. Looks good. Thanks. The diagnosis forms we get back from you help us track persistent concerns. Armed with that information, we can get engineering going on product improvement. If you don't tell us what your diagnosis turned up by sending back a completed diagnosis form, we're deprived of the best source of information we have, you and your fellow techs. By the way, when you receive a CD4E automatic transaxle through the FQR program, it comes completely filled with transmission fluid. If you get a unit from the factory, you'll have to add at least 5 liters of fluid before starting the engine. Then verify the level again. It may require more. Whichever CD4E you're installing, one from FQR or one from the factory, read any instruction sheets that come with the transaxle and double-check the transmission fluid level to prevent needless damage to the unit. To help you fix it right the first time, Ford Powertrain Division supplies information specific to transmissions and engines through the reference manuals and additional materials. An order form that fully explains these materials, including our comprehensive technical service bulletin manual, is included at the back of the program booklet.